At whatever time of the day you are watching this video, Sanbonani Emakaya, I hope you're having a lovely day and that you're just ready for the lesson. And as you can see, today we're going to be learning about stoichiometry. But before this lesson, can I just make an appeal to you that please like my videos and also subscribe to the channel. You will get notified every time I post in a new video. Now, straight into the lesson, stoichiometry. How do we define this one? This is simply a technique or a method we use to calculate or to predict the amounts of reactants used or the products that are being produced in a chemical reaction. Now, why am I writing these words in a different color? I'm trying to emphasize the words that are associated with reactants and products. So now the word associated with reactant is used. So reactants are used in a chemical equation or in a chemical reaction, and AMA products are being produced or they are being formed. Now, if I speak of an amount in this chapter or in this lesson, I'm simply speaking about the mass of a substance, the number of moles, concentration, or the volume. Okay? I've developed this formula to calculate and to predict the number of moles using stoichiometry. So let us go into this formula and try to understand it. This is the number of moles of substance number 1 divided by R1 equals to the number of moles of substance number 2 divided by R2. So let us define the variables. The number of moles of substance 1 and substance 2 are simply the moles of substances we find in a chemical equation. So S1 and S2 cannot be a substance that is not in the equation we're talking about. Okay, you've got to have a balanced equation, and then you use the substances that are in that equation in this reaction. You can't use anything different. Okay, let us continue now. What is R1 and R2? These are stoichiometric ratios or coefficients of substances 1 and 2 respectively. Now, I did mention that a balanced equation is necessary to do AMA calculations under stoichiometry. Now, how to use this formula? These numbers are going to be balancing the chemical reaction, so it's easy. So this number is balancing S1 in the chemical equation. This number is balancing S2 in the chemical equation. And of course, that means you're going to be looking for one of the number of moles. You're going to be given one of the number of moles and you're looking for the other. Okay, one is known and the other is calculated. And these values R1 and R2 will always be substituted. We're not looking for these values because you take them from the chemical equation, a balanced chemical equation. Let us do examples to explain what I'm saying here. 2 moles of nitrogen react with hydrogen to produce ammonia. So now, number 1, if you are lucky, you will get this question from an examination. But remember, it's necessary that you always answer this question even if it's not there. You always need to have a balanced equation. If you're not given, do not wait for the question. Go straight into the answer sheet and then write down a balanced equation before you answer the questions. Now, I want us to answer these questions. 2 moles of nitrogen react with hydrogen to produce ammonia. Question number 1, write the balanced equation. So what will be the balanced equation? It's actually between a nitrogen gas plus a hydrogen gas. Remember, these are diatomic molecules. You'll have to remember what are diatomic molecules. They exist in pairs, so they do not exist as one. So now NH3 is also a gas. Now we need to balance this chemical equation. So we have 2 nitrogen atoms, we have 1, so you can see that we need to multiply this by 2. Now we have 2 nitrogens, they are fine, but all hydrogens, they are now 6 on this side, so we've got to multiply by 6 on this side as well. Now let's answer question number 2. Question number 2 says, calculate the volume of ammonia produced at SCP. So we understand at this point that at SCP we do have our go-to formula that calculates the volume. So we understand that at the end of this calculation, we should have used this formula. V over Vm is equals to the number of moles. Okay, so in this question, we are looking for the volume of ammonia. So I always specify what I'm looking for. But do we have the number of moles? We don't. But this one you're not worried about because this is simply our constant, which is at 22.4. Now we need to find the number of moles of ammonia. What are we given here? We are given the number of moles of nitrogen to be 2 moles. I always write down next to the substance what I'm given, and I'm looking for this number of moles because we understand that if we can find this number of moles, we're going to come back here and put them here and then find the volume of ammonia. So we're going to use our equation. Number of moles of substance 1 should be equal to the number of moles of substance number 2. And remember to divide this by their corresponding stoichiometric ratios, or R1n and R2. So which one do we choose as R1 and R2 in this case? Remember I said one you should be looking for and the other you should know. Remember in this formula we don't use the mass, we don't use the volume, we don't use the concentration. We simply use the number of moles. Now let us substitute here. So this is going to be number of moles of nitrogen, and this number balances nitrogen on this reaction. Let me put this imaginary one. And then this 2 balances ammonia in the chemical reaction. So let us substitute here. What are the number of moles of nitrogen? We are given that it's 2. So this is going to be 2 over 1 equals to the number of moles of ammonia over 2. So now if we cross multiply here, 1 times the number of moles of ammonia, the number of moles of ammonia should be equal to 4 moles. So I always label this as produced or used. But why do I say produced in this case? It's because we're speaking about a product which is ammonia. Now I go back to that equation. I'm going to substitute the number of moles here. So the number of moles are equal to 4. We are looking for the volume of ammonia, NH3, and then divided by the molar gas volume, which is at 22.4. So now what is this value giving us? So when you cross multiply here, the volume of ammonia, NH3, should be equivalent to 89.6. Remember the volume is measured in decimeter cubed. Let us answer the following question now. I'm just going to put this on the side. The following question says, calculate the mass of hydrogen that is used. So what we're going to do, we know that this is the formula that calculates the mass of a substance. So that means finally we're going to come back to this formula. But for now, do we have the number of moles of hydrogen? No, we only have the moles of nitrogen to be 2 moles. And we also have this number of moles to be 4 moles. So what we can do here is to use our equation to find the number of moles of hydrogen. Remember, use our equation if you want to find the number of moles, but you've got to use another substance where you know the number of moles. I'm going to choose this one and I'm going to write my equation. Okay, I have written my equation and I'm choosing my substance number 1 to be hydrogen and ammonia. Remember, one you should be looking for and the other one you should know the number of moles. Now, we need to divide this by their corresponding stoichiometric ratios. What is balancing hydrogen? It's a 3. What is balancing nitrogen? It's a 2. You could have used this one instead of ammonia because we do know the number of moles of nitrogen. Now, let us continue. So, we calculating the number of moles of hydrogen, we don't know them, divided by 3. But this number of moles here are 4 over 2. So now this value is simply equals to a 2. It simply equals to a 2. So now how can we remove this 3 here? We can multiply by the 3 on both sides. So what does this become? So this would be 2 times 3, which will give us the number of moles of hydrogen being equals to a 6 mole. Now we can come back here and substitute. So we know the number of moles to be a 6 equals to, we are looking for the mass, and then let us calculate the molar mass here. We have 2 atoms of hydrogen, but each hydrogen is equals to a 1. Let me use in the square brackets rather. So now 2 times 6, what does this give us? The mass of this atom will be at 12 grams.